My name is Wang. I come from Alibaba Group, working as a security researcher. And my research focused on the IoT, V2X, and the cyber physics system, or something like that. Today, I would like to walk you through some old threads, but due to some new devices that we could look at in another new way. So the introduction and outline would be, first I will, there are a lot of devices that still using infrared as a control surface, such as the air conditioners, the TVs, and the camera and speaker DVDs, and so on. And also there are some devices that are transmitting IR signal that we haven't noticed before. And we will discuss the possibility to use a slow motion camera within your iPhone, no, not iPhone, with your phone to do some infrared experiment and see what we can get from the infrared controllers. And finally, we will discuss the high power infrared transmitters, if we can control something like that. Okay, this is a short review of the existing technology. Basically, the infrared controllers, the remote control, has standard called NEC standard. Basically, you can see the pulse, the duration of the pulse. If the pulse is around 562.5 microsecond, it's then followed by a space that equal to the duration, then it's logical 0. And if logical 1, the space will much longer, and twice. So basically, this could be seen as a modulation of duty cycle. So the logic 0 is duty cycle 25%, and the logic 1, the duty cycle is it's 25%. So the NEC standard has some FEC, sort of the forward error correction mechanism, such as there will be a leading pulse burst followed by twice of the transmitting data. The first one is the regular one, and the second part is the inverse of the logic. So it's a very old technology, and but it has been considered as a very successful scheme during the history. So you may ask, tell me something I don't know. Yeah, the first thing I want to show is that why the infrared using the wavelengths of around 940 nanometers. So as you may see, this is from academic of United Kingdom, so water vibrational spectrum. As you can see, the upper bound of the visible spectrum from here, this is basically the absorption coefficient of the water. So the infrared part will be absorbed by the water in the air. So the remote controllers receivers cannot be interrupted by interfered by some part from the solar light. So this is what part the first part of this design, and the second part is why there will be a carrier of around 38 kilohertz. Basically, the designers of the IR remote controllers, they want to use a simple band filter to filter out all of the irrelevant the interference out of it. So this is why the 940 nanometers infrared light is widely used. So if we want to get the remote controller's code, there are several methods to get it. For example, you can use existing libraries, such as from the Linux infrared control. This project has a lot of people to contribute the existing measurement, and you can find your type of controller. If you are lucky enough, you just download the configure file, and you can get a lot of them. It just works. And also there are other projects such as IRDB. And if you want to design some gauges, you can use some remote controls receiver module such as TSOP series to very easily to design one of it. You just to count the duration of the pulse, and you can get the code. And I want to show you the possibility of the third part is the cell phones. So before that, let's take a look of using a Raspberry Pi. You just connect the black part is the LIRC. It's a remote control receiver module. Basically, it has a bandpass filter of around 38 kilohertz and filter out and do the carrier filter out with the carrier pulse. Then you can get the pulse, the signal pulse of it. And I just tried it with my own remote control, and this one was the space and pulse time. It recorded, and I can easily recover to this series of 1 and zeros, and it's just the same from the LIRC's configurations. It's so it's very simple one. So what we want to do is try to utilize some modern cell phones, such as this one. It's from Samsung Galaxy S10, I think. It has a capability of 960 frames per second, and the playback speed is around 30 frames per second. So the ratio is 32, right? 32 times. You can see, yeah. I pressed the button, and we can see the blinking part. So this tells us two things. First, the speed is is very fast, actually. And the second part is the infrared filter of that phone is very tolerance. It has very tolerance. So we can get the infrared part of it recorded. So I upload this part of video and using FFmpeg to get each frame of it. And then I renamed the frame that contains the red dot to adding some dashes. So if you can see here, actually this line was file names. It's transposed to horizontal mode. So the with dashes that has red dots, I compared it with our existing measurement of it by logic analyzers. And some interesting part is this pulse can be accurately aligned to our results. Actually, I couldn't afford one of the Samsung S10. The whole experiment was done in a shop. I didn't buy it. I just fetch a remote controller, done the experiment, and upload it to YouTube and get it. So you can done it. A lot of S10 around. Yeah. So this is alignment. Is very yeah. This is the file names, and this is the 312 frames and the 09 frames is aligned very accurately. So from the specification, this duration should be 108 milliseconds, and during our measurement, 301 minus 197, and divided by the frame rate, and we can get the number. It's I think it's good enough for this part, especially we haven't buy it. This was a very lucky example, but this was another example that is not so lucky. This part is the one is 351 microsecond, and the pulse is around 1600 microsecond. So if you can see these animations, if you remember, you could recall from the oscilloscope, when you haven't configured the trigger. So basically, this part can be seen as the oscilloscope works in a free run mode. So sometimes you got the 0, sometimes you got the 1, but if your resolution is fast enough, like around 2000 FPS, this shouldn't be a problem. You remember the Nyquist theorem, right? But in in our case, the FPS, the frame rate, is roughly the same as the data rate. So we have to do some video at trigger so that only when the 351, the duration comes down, the calculation starts, so that the 960 FPS works fine. This is the first point. And the second point, remember the NEC standard, they have two paths of it. And the first path is a regular data, and the second path is inverse data. So we can use that to do some, basically this is a undersampled signal recovery problem. I think, with some little, communication trick, DSP trick, we can, use the slow-mo camera as a poor man's signal, logic analyzer, maybe. Okay, the second part I want to share with you is the infrared filling light. Most of it comes from the surveillance camera, like this one. The surrounding white bulbs are the IR filling lights. There are more of it, especially like this one. Two of it. Actually, you cannot see. You can barely see it with your eyes, but you can see it through your phones. Because the phones has some IR filters. Some of them has some tolerance. So this one, when the night is dark and full of terror, there will be a surveillance camera. Yeah. So I prepared this joke for a long time. Oh yeah. And this one is another kind of the illumination light. And this is a clocking machine, and this is a illumination light, and you point your face at this camera, and you're gonna be paid. This is another camera. Actually, these pictures are mostly taken back in my country, but so I bought some very simple IR filling light. This one is around 3 watts. It's a very strong one, but only this much of size. And the red part is photo resistance. We will discuss it later. So you can just feed it with power, and it turns on. So I have taken some pictures in the digital store, and I found a lot of the same designs yesterday actually, like this one, and the IR filling lights, all of them. So I took one of it apart, and I found that basically it can be powered through the power over Ethernet cable. And second, there are two of the boards. The first one is the power supply board, and the second one is the main control board. And this plug is the IR filling light. So the IR filling light, what we don't know yet is if the filling light is 940 nanometers or not. And second, the switching speed is it can be fast as 38 kilohertz, right? And the third one is, will higher transmission power make a difference? Remember the water absorption in the air. So maybe we have the three things we don't know yet. So several experiments are needed. This board is designed by Dr. Yang. He couldn't make the trip here. Basically, this is a FPGA head for Raspberry Pi, and with an interface for infrared, so we can easily program it into an infrared recorder. So this is the first experiment. So this black part is the IR receiving module. So we are feeding it with 38 kilohertz. So as you may see, play it again. The blue dot indicates that it's receiving 38 kilohertz. So this part is without any remote control code. It's only with the carrier for to check whether it can transmit 940 nanometers the light, and the control board doesn't filter out the 38 kilohertz. So we tried it with another larger one. This is actually from the filling light from the pole. It's a very strong one, so it also works. You may see here. So we use our infrared recorder so that when we press the button and the air conditioners, you can hear the beep. The air conditioners is turned on. So the next experiment is we want to check the power. The strong power will make a difference. As far as I know, across two of the gates, we can still use the strong one to turn the air conditioner on. But I don't have a video for you. But actually, we got two around this distance, the doors, and the air conditioner still can be turned on. So the next part we want to discuss is that the attack scenarios when the surveillance camera is attacked through the internet. So what can the attacker do without with this IR illumination light? So remember the Pi-FM project is very hacky project that utilize the GPIO of a Raspberry Pi to emit FM signal around 90 megahertz. This is possible because you can use DMA mode to generate some ones and zeros and use the GPIOs just to send out the signals. So you don't need to worry about the CPU, the speed of the CPU or anything else. So we checked one of the developer manual from the surveillance camera. And you can see the IR LD control is connected directly to the GPIO and PWM. The next demo is this was my remote control, and this is a commercial off-the-shelf surveillance camera. So the demo is when the camera is hacked, remote hackers can use this control your TV. Even this one was with a browser, so it's an Android TV. So you can type in an URL and to get a website loaded. This was it. So what could possibly go wrong? Remember the printer thing a few days ago or a few months ago? Maybe someone could turn on millions of air conditioners at the same time to cause a power surge of the grid, right? And for the internet connected TV, some of the TV can have in-TV purchase mechanism. So we can force them to buy some fancy videos from HBO or botnet-like behaviors. This was the case. Yesterday, I also take some picture in Amsterdam, and this one is exactly the same kind of the surveillance camera with IR feeding light, and the TV is just around the corner. Actually, the TV is facing another surveillance camera. So the next thing I want to discuss is the photoresistance. Actually, this photoresistance is designed for when the night. When the night comes, the feeding lights could be turned on automatically. So is it exploitable? But it's not that kind of exploitable. I checked the manual. The response time of the resistance is about 30 milliseconds. So we cannot do so much of things with it. But just maybe we can point a laser or like a fan around it to make it illuminating. So maybe this page is workable for the more fancier hackers. So looking at the bright side of this thing, this one is from the old Kerk, the church in the center of Amsterdam. This is the audio guide. You can borrow it from in the entrance. If you point this audio guide to this thing under the picture, the audio guide will show the related information. So I took a look at it and found maybe you cannot find it. The gadget on the wall actually is a transmitter. It's transmitting infrared things. So this one is actually a receiver. So you have to point it at the transmitter to get your ID. So what we found here is another security surveillance camera with IR feeding light, and it's internet connected. So looking at the bright side, maybe this could be use a IR watermark because it's transmitting and is connected directly to GPIO, its program, and is internet connected. So maybe you can use it as a watermark during your filming or during some, you just point it at the pictures and the camera just pop-ups the related information. Maybe this is a bright side. So one more chapter is a Pullman's spatial light modulator. This one is a commercial from Kaspersky, indicating that there is a birthday party and the hackers hack a fan and ask for money.
Go hack yourself, hackers.
So what Kaspersky think, I think he's right.
There is nothing left to hack.
Yeah,
when
there's
your
nothing left to
business
hack.
is protected by.
Yeah, I think he's right because hacking a fan doesn't matter. But who said hacking a fan doesn't matter? So we done some research at the RPM, the revolutions per minute. As for DVD, that around 10 kilo RPMs, and for a car, the wheels is around 700 RPM, and for the electric drill, that is around 10k to 50k. For a regular fan, it's around 1500 RPM, and ceiling fan, not fancy, and server fan. This one is a server fan. It can be 20k. So remember the 38 kilohertz? Maybe we could just drill some holes on the disk or on the fans. We can get 38 kilohertz. So that hacking a fan could turn on your TV. Maybe for the HDD, it's around 7200 RPMs, and air propeller 2400, and the drones around 5k. So this one has 84 holes. Maybe someone could work it out. So some of the future works, including some of the professional slow-mo cameras, it can as fast as 20k FPS. And second, from the recently published work called VFT, it provides a simple, useful, and accessible form of compressive sensing. Basically, I think remember the CCDs of it is basically is swapping. But this paper said it can be used to the dynamic range of the photograph, the photo can be used to speed up your camera. This could be, but this cannot be used in the IR case because our IR case is still, but it's very useful during a dynamic. It's a moving part. So maybe we could use this feature of the camera to detect some spy cam. For example, some spy cam only works at night, and the IR video watermarks. One more thing before I wrap it up. This is an S10. Behind it is an iPhone 10. So you can see the dots. Yeah. It's this structural facial detection is also emitting IR. So the key takeaways of this talk is one, the switching rate of the IR filling light is enough for infrared remote controlling, and the infrared and the countermeasure should be we should disconnect the GPIO and the IR filling light. And the second takeaway is the 960 FPS, the cell phone camera is able to work as a poor man's logic analyzer, and homemade like light choppers could be easily developed by drilling some holes on a disk. And for supply chain risk, I think if you purchase some surveillance camera, maybe you have to check the or other things like regular DVD players. You should check the LEDs to find whether the LED is a regular LED or it's a IR emitting LED. I think this one could be quite easily used as a supply chain risk. So, thank you. This is all my talk. Hope you enjoyed it. Any questions?
Well, thank you very much. Are there any questions? Okay. Well, no, thank you then.
Okay.
The slides will be online and the next talk will be in half an hour.